Hi guys, so I honestly don't remember what episode we're on, so this is just going to be called Lesson 6.1, Ratios and Rates. And so in this episode, you will learn different ways to represent ratios, how to write and solve a ratio, how to find a unit rate, and how to convert between different units of measurement. So each of these pieces we've done a little bit in class, but this is going to be a general overview of kind of what we're going to be doing in this chapter. So I showed this today in class, but a ratio is a comparison of two quantities. Just like what we did today with our shadow activity, we compared our shadow height to our actual height. And we can write a ratio in three different ways. We can write it using the word to, we can write it with a colon, or we can write it as a fraction. If you notice the fraction, the 3 is in the numerator because it comes first in the colon and it comes before the word to. An equivalent ratio is a ratio where the two quantities are the same. So for example, 3 over 2 is equal to 30 over 20 because we're scaling up by 10. So those are equivalent ratios, or we would also say equivalent fractions. So how do we write ratios? So this is our first example. So it says an archer shoots 60 arrows at a target, with 44 arrows hitting the target and 16 missing it. So the first part says to write a ratio of the number of hits to the number of misses. And so I'm going to put my number of hits in the numerator because it comes first. See how it says number of hits to the number of misses? So the number of misses in the denominator. So if we look back to our information up here, it says that the archer hit it 44 times. So my 44 is in my numerator. They missed it 16 times, so 44 sixteenths. And then if it asked to simplify, we would say, well, 44 and 16 are both even, so I know 2 is going to go into it. And I also know that I can then simplify it further to 11 over 4. Sorry, I was just making sure it was still recording. And so then my question says, would it make sense to write the ratio as a mixed number? Since 11/4 is improper, do you think it would make sense to compare these quantities using a mixed number? Well, we could write it as a mixed number. So 11/4 equals 2 3/4. So if we want to think about this as a ratio, I could think about this as 2 3/4 over 1, right? Because dividing by 1 doesn't change the quantity. So if I think about this as 2 3/4 over 1, that means for every one miss, right? Because misses is in the denominator, I would hit the target 2 3/4 times. So if I missed 2 times, I would double 2 3/4 to figure out how many times I would hit the target. Now, 2 3/4 doesn't make sense in terms of hitting the target because you can't hit the target 3/4 of the way. You either hit the target or don't. But we kind of have to think about it as an average that you would hit it between 2 and 3 times every time you miss. So again, if we wanted to think about this same example but write a different ratio, we could write the ratio of the number of hits to the number of shots. So we know the number of hits is 44. The number of shots is given in this word problem as 60. So now my ratio will be 44 to 60. I could simplify it to 11/15. So we can write lots of different ratios for one word problem. So unit rate is a little bit different in that unit rate is a rate when the denominator or the numerator has a 1 when in fraction form. So kind of another way to think about it is you're thinking about how much does one thing cost, or how far can you drive in 1 hour. So the number 1 is key when we're thinking about unit rate. So unit rates are often indicated by the word per, like miles per hour, words per minute that you can type. There's lots of different things we can use with the word per, and it means for every. So if I say miles per hour, that means the miles that I travel per 1 hour. So this was the example that we did as our do first. We said you can host a party for 12 people. The food and drinks for the party cost $66. What is the cost per person? So what each of y'all did is you did 66 divided by 12. And so when we think about doing 66 divided by 12, that gave us $5.50. So we could think about this as a ratio of the number of people over the total cost. So I'd be doing 12 over 66. Or I could think about this as the total cost, which is $66 over 12. This is the correct way to solve this word problem, but this ratio would also be accurate if this question was different. If it maybe said, for $1, how many people could you serve, right? We wouldn't be able to serve actually a full person for $1 because it's kind of expensive. So this would be the correct ratio that we would want to use. So in thinking about the ratio that I was like, that's maybe not the best way to think about it. Why it does work is if we think about 12 over 66, and I simplify 12 over 66, 12 over 66 is equivalent to 1 over $5.50. So that tells me that one person cost $5.50. So we actually could think about it this way. But most of you, for the do first, thought about it the other way, putting 66 on top and 12 on the bottom. Another example is Evan purchased 24 muffins for $15 to sell at a bake sale. What is the cost per muffin? So I want to find the cost per muffin, so the cost for one muffin. So I can think about this as the ratio of muffins to the total cost. So 24 over 15. Now I want to find the cost for one person, right? So that means that I can divide by 24 in my numerator and by 24 in my denominator. So if I divide both by 24, I'm doing 15 divided by 24. If I think about this as a fraction, I can simplify it to 5/8. Then I can use my calculator or simply divide to get 0.625. Now, since money, we don't use the thousandths place, we use the hundredths place, we would need to round. So it would be about 63 cents per muffin. Now, some of you might be thinking, well, what if we just divide 24 by 15? Well, if I divide 24 by 15, that will give me a mixed number. If I do 24 divided by 15, that will be in my denominator, and that would be a little bit confusing. So it's easier to think about it as 15 divided by 24 because we want to scale down to get the cost for one person. So for one muffin. So each muffin costs 63 cents. So we can also use unit rates when we're thinking about measurement, either changing meters to kilometers, feet to inches, and here we're thinking about money. So it says, suppose you made $33,000 per year. How much would you make per month? Well, to answer that, we need to think about how many months are in a year. So since there's 12 months in a year, we can think about our ratio like this here. So since I know that I make $33,000 in a year, that means I also make $33,000 in 12 months. So to figure out in 1 month how much money I'm going to make, I'm going to do $33,000 divided by 12 because 12 divided by 12 is 1. So 33,000 divided by 12 will give me X dollars. So when I do this, I'm going to get 2,750. So that means that if you make $33,000 per year, you make $2,750 per month, which is reasonable because you'll make less per month than per year. So this is our last one. Yes. Okay. So it says a fighter jet travels 300 miles in 20 seconds. How many miles does it travel in 1 minute? So I set up my ratio here of miles to seconds, and I want to figure out how far I travel in 1 minute. So this is going to be a little bit different here because since there are 60 seconds in a minute, I can set up my ratio like this. Or I could think about how do I write 20 seconds in minutes. So since there's 60 seconds in a minute, 20 over 60 is going to be 1/3. So I could think about this as 300 miles over 1/3 minutes, or I could think about, well, I need to get this to be 60 seconds. I'm scaling up by 3, so I can multiply 300 miles by 3. So the fighter jet travels 900 miles in 60 seconds, or 1 minute, right? Which is reasonable because if in 20 seconds it travels 300 miles, in 60 seconds it'll be able to travel 3 times as much. All right, guys, I know that was a lot of information to get through. If you want to scroll back through and look through some of these examples, then on Friday we will discuss more. Thank y'all for your time.